to my YT channel. This is again I'm a singer eternal voice. Now we will be able to solve some problems with regards to the basic science formulas. Okay? So we have question number 1. What is the weight of a large spherical balloon filled with air with a density of 1.29 kilogram per cubic meter that has a radius of 10 meters? The mass of the balloon skin is 0.35 kilograms. A. 41,110 Newton. B. 53,110 Newton. C. 61,210 Newton. D. 52,959 Newton. E. None of the above. Okay, let's solve. So what is being asked in the problem is the weight of the spherical balloon. Okay, so we have here. Got it. So weight of the spherical balloon. So this is weight is equals to mass of the spherical balloon times the gravity. Okay, equation 1. So this is our equation 1. Okay? And then we have a spherical balloon. So a spherical balloon. Okay? So like this. Okay, and a spherical balloon has a volume of 4 over 3 pi r cubed. Okay, spherical balloon has a volume of 4 over 3 pi r cubed. Why I put this one? Because it's needed in the formula of density is equals to mass over volume, and in our weight formula there is a mass, so we can get this volume first if you want. Okay, it's really needed. Okay, right? And the density of a spherical balloon, okay, spherical balloon plus air na siya, okay, is equals to 1.29 kilogram per cubic meter. Okay, density of a balloon and the air is 1.29 per kilogram per cubic meter. So in here alone, we can solve for the mass by using the formula density is equals to mass over volume. Okay, density is equals to mass over volume. So the mass will be equal to the mass of a spherical balloon will be equal to the density of the spherical balloon times the volume of the spherical balloon. This one. We need this mass because for the weight. Okay. And take note, the mass of the balloon skin is 0.35 kilogram. Balloon skin, okay, so meaning to say the balloon, the outer parts of the balloon, right? So the mass of the balloon skin, ganon. Balloon skin is equals to 0.35 kilogram. So it is expected that the total mass will be the mass of the balloon skin plus the mass of the air. This is equation number 2. Okay, equation number 2. Okay, like this. Total mass equals to the mass of the skin's balloon plus the mass of the air. We don't have the mass of the air yet. And we can compute that mass of the air through using the formula density is equals to mass over volume. Okay? So, the density is 1.29. This is the combination density, ha? To make it safe. Okay? The air and the balloon. Okay? Inside the balloon, something like that. Okay? Then the volume now will be 4 over 3, this one. So 4 over 3 pi 10 raised to the power 3. Okay. So Sotero, where is that? Because there's a radius of 10 in the problem also. Okay. So very good. All given are perfect. It's there. You don't have to analyze very well. Okay, because it's given. Okay. It's like this. Okay. So 10 times 10 times 10 is equals to times 3.14 times 16 is equals to times 4 is equals to divided by 3 is equals to times 1.29 is equals to 5,403. This is the mass of the spherical balloon. 5,403. Oh, air. Sorry, air pa ni siya. 552. So, i-add din mo siya. Total. Okay, so mass total will be 5403.552 plus 0.35 is equals to, oh my gosh, the mass total is 5,403.902 kilogram. Okay, the total mass of the air and the balloon is, spherical balloon is 5,403.902, and it's substituted in equation number 1. Okay, so 5,403.902 kilogram. I will never write the unit anymore because no more space in the paper. Okay, times the acceleration due to gravity is 9.81. So this is kilogram meter per second squared is Newton, the unit of the force. Later I will discuss to you why. So 5,403, okay, to the power 3.902 times 9.81 is equals to 53,012. Okay, the answer is letter B. 53,110 Newton. Okay? Choice number B. Okay? So it's 53,110 Newton. Answer. So, Sotero, why Newton? Newton is a unit of the weight. The same as force because that is directed downward or upward. The balloon will go up, right? Vertical. So it could be either two, going downward or going upward. So the weight will always be equal to Newton as the unit. It's not the kilogram. Okay? The weight is Newton all the time. Okay? Not kilogram. Kilogram is a mass. Okay? Because this is for the gravity. Okay? So the weight of the spherical balloon is 53,110 Newton in going to the sky. Okay? That's question number 1. Question number 2. 30 liters of water with a density of 1,000 kilogram cubic per meter is mixed with 50 liters of ethyl alcohol, density of 789 kilogram per cubic meter. What is the density of the mixture? So A, 1,789 kilogram per cubic meter, B, 918 kilogram per cubic meter, C, 445.5 kilogram cubic per meter, D, 868.12 kilogram per cubic meter, E, none of the above. Okay, but before that guys, the density of air pala siya, constant siya talaga, 1.29 kilogram per cubic meter. So this another knowledge. Okay, we have the density standard of water, 1,000 kilogram per cubic meter, and the air also, AIR is 1.29 kilogram per cubic meter. Standard. You always use that density. Oh no, yes, for a problem solving that involves air. Okay? If it is not mentioned there, the density of air is automatic to be like that. Okay? Air and water. Okay, mayroon na, di ba? So put that in your brain cells. Again, density of air standard 1.29 kilogram per cubic meter. Density of water 1,000 kilogram per cubic meter. And the rest of the units will be solved through conversion factors. Okay, if you know the conversion factors for this, gram to, like this, going to cubic meter, going to cubic centimeter, going to gallon, like this, everything. You will convert because there are lots of units, right? But just focus on the one unit na lang siya, kilogram per cubic meter, okay? But in chemistry, it's different, right? Because it's gram per ml all the time or gram per cc all the time. But in physics, or in the transport phenomena is always kilogram per cubic meter. Okay, but anyhow, you can convert. No problem. Okay. Now, I'm just telling you that there's a standard density of air which is 1.29 kilogram per cubic meter aside from the water which is 1,000 kilogram per cubic meter. Okay, now, so I will solve now number 2. Okay. Guys, this is mixture problem, huh? The same as solution problem. Okay, solution composed of a solute and a solvent. And in here also, these are all liquid. So, solute and solvent. But in here, we don't know yet which is the solvent and which is the solute because all of them are liquid. Okay, but based on our analysis, the solvent will always be water. Okay, so our solvent is water, our solute is ethyl alcohol. Okay, so this comprises of a solution or a mixture, combination of two substances. Okay, so why we say ethyl alcohol? Because anything man siya, if we add liquids, automatically our solvent will be water. But if the water is not present in the solution in a mixture, the liquid or the solvent there being added is our solvent. Okay? For example, sodium chloride is added with alcohol or ethyl alcohol. So your solvent will be ethyl alcohol na it's not water. Okay? Parang ganun siya. Okay? My point is, it doesn't mean all the time that the solvent is always water. Okay? But it doesn't mean also that the solute could never be a solvent. Again, it doesn't mean also that the solute could never be a liquid. Okay? Like that, because you have an idea that the solvent should always be liquid, like this. It depends on the situation. Okay, like this to consider which is the solute, which is the solvent. Okay, but most of the times this water really is the solvent. Okay, like that. Okay, so to understand lang siya. Okay, so we have here, so density of mixture again, class. Density of the mixture is equals to mass of the mixture, okay, over the volume of the mixture. So our mass of the mixture class will be the each mass, okay, which is mass of alcohol is equals to density of the alcohol times the volume of alcohol plus the mass of water, okay, which is volume of water times the density of water, then over the volume of the mixture. Here it's very clear that our volume of the mixture is equals to 30 liters plus 50 liters siya. Di-add lang siya, as simple as that. So 80 liters. Okay? Ganon. Okay? Then density of water, 1,000. Actually, class, even though the density is not given here, you can solve also directly because this is standard, as I told you earlier, if there's no temperature mentioned in a problem. For example, if I will revise this problem number 2, 30 liters of water is mixed with 50 liters of ethyl alcohol with a density of 789 kilograms per cubic meter. What is the density of the mixture? So you can still solve for the density of water directly because it is standard. Unless temperature is mentioned in the problem, that it will vary. Okay? But there's no mention of the temperature. Okay? So automatic, use the standard density of water. Okay? Like that. So it is also expected that this density of ethyl alcohol also is at 4 degrees Celsius. Okay? Because there's a 1,000 here, something like that. So it must be parallel with each other. Why? Because they are mixed with each other. If they are mixed with each other and combined with each other, automatic, the temperature of the other component will be equal to the temperature of the other component. So basically, technically, this 789 kilogram cubic per meter density of ethyl alcohol is at 4 degrees Celsius also. Okay? Like that. Oh, this is because the water is 1,000 for degrees Celsius man siya. So equilibrium. At equilibrium temperature, we obtain a density of ethyl alcohol which is equal to 789 kg per cubic meter, the same as water at 4 degrees Celsius. O ganon. Okay, so density times the volume of water is equal to, volume of water is 30 liters. Okay? And then, plus 789 times 50. Yung muna siya. Okay? So, 789 times 50 is equals to 39450. Okay? 39450. 30 times 1,000. 30,000. 30,000 divided by 80. Okay, so 30,000 plus 39,450 chart divided by 80 is equals to 868.125 density of the mixture between ethyl alcohol and water. Okay, so it's letter D in the problem of 30 letter. This is number 2. Okay, 30 liters of water with density of 1000 kilogram per cubic meter is mixed with 50 liter of ethyl alcohol with density of 789 kilogram per cubic meter. What is the density of the mixture? A, 1789 kilogram per cubic meter. B, 918 kilogram per cubic meter. C, 445.5 kilogram per cubic meter. D, 868.12 kilogram per cubic meter. E, none of the above. D is the answer. It's also the same with our computation here, which is 862.125 is near to 868.12, almost perfect. Okay, so this one. So see you later, guys. Only 2 problems, and later also we will be solving another formula. Okay, I'm trying to give an example for each science formulas, 30 science formulas. So this one is for the weight and for the density, and later for the other science formulas also. Thank you so much for watching this live stream. If you like this live stream, then you can subscribe my YT channel if you are not subscribing yet, and you can click the notification bell from some newest updates of I am seeing return of voice. Bye bye, God, everybody, God bless. Okay, thank you so much.